ladies and gentlemen, welcome to the AGM and meeting of the All-Party Parliamentary Group for Motor Neurone Disease. I'm Andrew Lewer, MP for Northampton South and Chairman of the APPG. I wonder if I could start by asking everyone if they could put themselves on mute unless they are actually speaking, which will assist. And if people are also able to turn off their cameras, that does help with the quality of the picture for the speakers, and particularly when they're making their presentations. Wanted also just to be clear with everybody that the meeting is being recorded, and the meeting will be available on video publicly after the meeting. So it isn't one of those we're recording it so we can take some notes ones. It actually is a full-blown recording, and there'll be a few screenshots being taken in the course of the event as well, in order to assist with the Motor Neurone Disease Association's publicity and raising awareness with as many people as we can about the disease, but also the work that we're all trying to do to assist. So all of that said, the first item, as it is an AGM, is to proceed to the election of officers. All the current officers have agreed to stand again, plus one new vice chair, which is Jessica Morden, which I'm very pleased about. And I was proposing that I would read out the current list of officers of the people who, many of whom are on the call, who've agreed to stand again, and then just ask if there are any other MPs or peers who would like to be vice chairs, if so, to speak up at that point, and then we'll take it as a block if people are happy. So I'm happy as chair to continue as such, and the vice chairs who are happy to continue are Brendan Clark-Smith, Chris Evans, Christine Jardine, Mark Tammy, and as I said, Jessica Morden as a new vice chair, and Rosie Duffield as treasurer. Are there any other MPs or peers here who wish to add their name to that list? Obviously, you can just be a member and just attend meetings and so on without being a vice chair, so we're quite happy to take them, but it doesn't preclude you from any of the activities of the APPG. So if there are, yeah.
Andrew, it's Christina Rees here. You can add me as a vice chair. I would be delighted. Thank you.
Oh, thank you very much. That's excellent. We'll add you to the list there. Thanks for that. If there are,
sorry, Barbara Keeley.
Yes, Barbara. Thank you very much. Absolutely. Any others before I take the vote? Okay, so with that as a block, are all the MPs and peers on the call happy for that list to go forward? Right, thank you. I'll take that as a yes, thank you very much. And the other item of housekeeping is to say that the Motor Neurone Disease Association, MNDA, is happy to carry on as the secretariat of the APPG, and I'd like to propose that and ask if we're all happy about that. And if there's no dissent from that, then I'll take that as agreed as well. Great. Thank you very much. If, as I said earlier on, if people are able to mute their microphones, it does just assist with the progress of the meeting. Thank you. And the next item on the agenda is to talk about an update on motor neurone disease research. We've got three speakers here. Speakers number 1 and speakers number 2 will be using slides, which they are going to deal with the tech, thank goodness, for. So our three speakers are Dr. Brian Dickey, who's Director of Research Development for the MND Association. And Brian's going to talk about MND research nationally and globally, some of the recent discoveries and what the future might hold, which I think many of you were on our last meeting will recall that reference was made to some really significant advances. So good to hear a little bit more about that. And on that theme then, following Brian, we've got Professor Chris McDermott, who's Professor of Translational Neurology at the University of Sheffield, and Chris, on that theme, will be talking about some of his groundbreaking gene therapy clinical trials, which will be really interesting. And then our third speaker will be Danny Baird, who's living with MND from Essex. Danny's going to talk about her experiences of taking part in Chris's clinical trial. So let's go straight into Brian, Dr. Brian Dickey. I'll hand the technology and the microphone over to you.
Thank you. Let me just see if I can find the right presentation. There we go. Can I check everybody can see the slides and hear that? Andrew, can you put your thumb up? Yep, fantastic. Great. Thank you, everybody. I guess I'm just the warm-up act for Chris and Danny, you know, who talk about some of the really exciting research that's hitting the clinic at the moment. But I thought I'd start with a few facts and figures, because there might be new attendees who aren't familiar with MND. Over 90% of cases of MND are a particular form called amyotrophic lateral sclerosis, or ALS. So the terms are often used interchangeably, and I may do that, and Chris certainly may do that in his presentation. It's a progressive neurodegenerative disease. It predominantly affects the motor neurons, and the motor neurons are the nerves that connect the brain to the muscles in the various parts of our body. So they convert thought into movement. And in motor neuron disease, effectively the lines are down, and what you see is progressive muscle weakness, muscle wasting, and paralysis. And that progression can often be quite brutal. A third will die within a year of diagnosis, and half within 2 years. It is considered a rare disease, but actually the incidence is in the same ballpark of multiple sclerosis. So the incidence of MND is 2 per 100,000 of the population per year. MS is about 6 per 100,000 per year. But the prevalence, the number of people living with the disease at any one time, is very different between those two diseases, and that's due to the high mortality in motor neuron disease. So you can see there the prevalence of MND, 6 per 100,000. For multiple sclerosis, it's actually about 200 per 100,000. The lifetime risk is about 1 in 300, and the level of that risk increases the older you are. And that risk equates to 200,000 of the current UK population who will receive a diagnosis of MND. So suddenly maybe it doesn't sound so rare after all. So I work for the MND Association. I have done for over 20 years now, and I've seen a lot of activity and a lot of growth. We've actually funded research for about 40 years since our inception, and we're currently supporting more research studies than any other UK funder. And this is mainly in the UK and Ireland, although we do fund in other countries as well, but there's always an element of collaboration with a UK researcher and institute to ensure that new knowledge and skills are imported to help to build up the UK research base. Collectively, charitable funding for targeted MND research from ourselves, the My Name's Doddy Foundation and MND Scotland actually exceeds government investment. I do need to emphasise the word targeted here, because there is a lot of government support for broader aspects of neurodegeneration, but that has often very variable relevance to this specific disease. The association also plays a key role in fostering international collaboration and information exchange, and it's particularly important in the rare diseases arena. One of the ways we do that most prominently is as organiser of the annual International Symposium, and that's the world's largest meeting on the disease. We normally have it as a face-to-face event, and we usually see over 1,200 delegates attend. We actually went online last year because of the pandemic, and we actually saw an increase in participation in both numbers but also in geographical reach. So we had scientists, clinicians, healthcare professionals from 48 countries around the world attend the 3-day online event. core philosophy for the association, because although we're a fairly large funder in MND research circles, in the grand scheme of medical research, it's a drop in the ocean. So what we have to do is work in partnership where we can, get as many bangs for our buck as possible. And that's not only through joint funding initiatives, but it's also in the underpinning research infrastructure, whether it be biobanks or clinical research networks, and also in communicating the outputs, the results of the research to both the specialist research community, but also, of course, to patients and public as well. The photo on the right is one of my favourites, actually. It illustrates the range of funders that support joined-up international research programmes. This is actually Professor Al Chalabi in silhouette from King's College London, and he was talking about a major initiative called Project Mine that we're involved in that is investigating the genetic basis of this disease. But you just get an idea from that slide that he put up at the end of his presentation how many different agencies and funders are involved in this sort of research. And I have to say, maybe it's the nature of MND that focuses the mind, but the MND research community is highly collaborative. There's no getting away from the fact that the development of effective treatments for these age-related neurodegenerative diseases, Parkinson's, Alzheimer's, MND, has been incredibly difficult. You know, these are highly complex diseases and they're proving to be tough nuts to crack. But we're seeing increasing optimism from the research community that we could be on the cusp of changing that, and MND is very much at the forefront. And in the next few minutes, I'm just going to highlight some of the reasons why. But for a start, what we're seeing is exponential, I'd say, growth in international research activity. That red graph there shows the number, red line there shows the number of scientific and medical research publications in MND since just after the war. And you can see in the last 10 years in particular, it's really increased dramatically. Just for comparison, I've put in two other progressive low prevalence neurodegenerative diseases, Huntington's disease, which I'm sure you've heard of, progressive supranuclear palsy, which is kind of a variant of Parkinson's, which you may not have heard of. And you can see that overall there's more research going on around the world than ever before, but there's something about MND that's really grabbed the attention of the international research community. And that's really being driven by that inset graph here, a lot of fundamental discoveries into genetic factors that prime people to develop MND in later life. I should say that MND is a multifactorial disease in the same way that Parkinson's and Alzheimer's is. Many factors will need to come together, genetic, environmental, aging, but in MND, there's a significantly higher genetic component. And what that means is that it gives us a starting point. And it's not as simple as you find the cause, you find the cure, but these discoveries into the genetic component of the disease give you this key starting point. You can take that knowledge into the lab and you can start to map out the disease course. And I often use the analogy of MNDs like a river. So just like MND has many genes underpinning the disease, particularly in the 10% of cases where the disease does run in families, a river has many different sources as well, but these sources form tributaries that all finally come together and converge in a final common pathway that leads out to the sea. And as we build up this map, this understanding of the disease based on the different causes, we can start to identify the points where the tributaries meet. And these are kind of the pivotal biochemical processes that are determining life or death for a motor neuron. And those can serve as drug targets that hopefully will address the disease, will attack the disease relatively early in the disease process rather than down near the mouth of the river where you've got 1 million gallons a second of water heading towards you and it's probably too late. But there's another strategy as well, and that is the one that Professor McDermott's going to talk a little bit more about, and I think it's really exciting, is that you could go right upstream and try and dam that river near the source. Now, that will only work for that specific tributary, that specific type of MND, but it also might be significantly more effective in those forms of MND because you're targeting a very upstream part of the degenerative process. So this is currently in clinical trials for 3 of these genetic forms of MND. And Professor McDermott will say more about this approach in his talk, focusing on 2 in particular that his hospital is involved in. So other aspects of MND that are really pushing it from what I would say 20 years ago was a relative scientific backwater to the forefront of therapy development include, first of all, the nature of this disease. The fact that it's rapid, generally consistently progressive, means that you can run several relatively simple clinical trials on this. And if it works for MND, the argument is if you can get it right for MND, you can get it right for these other neurodegenerative diseases like Parkinson's, like Alzheimer's disease. There's a lot of work going on now around what's called prognostic modeling. That's helping to predict how the disease is likely to progress within an individual. And this is, as an example, this was a publication that came out a few months after Stephen Hawking died. And this is his prognostic model based on something called the NCALS model, which used information that was available at the time of his diagnosis. And it predicts that he had a 94% chance of surviving at least a decade with this disease. Whereas, of course, when he was first diagnosed, he would have been given that diagnosis of maybe 1 to 3 years to live. The other key area where progress is being made is in what we call biomarkers. These can be neuroimaging, MRI scans, PET scans, analysis of cerebrospinal fluid, blood, etc. This is one particular biomarker called the neurofilament, where you can actually also use to start to predict the rate of disease progression. And you can also use these to effectively help us understand what's happening on the inside in the central nervous system, rather than having to solely rely on monitoring the outside physical changes. And that's particularly important, of course, in drug trials. And I have to say, MND's really been at the forefront of embracing new trial designs that have come out of the cancer world that will help us to run shorter, cheaper, and smarter trials. And we've already got 2 of these platforms that are in place. The MND Smart platform, which is started in Scotland, is COVID-19 permitting, going to roll out across other clinics across the UK, and also the international, mainly pan-European TriCals platform. So, we think the time is right for making a concerted push to develop effective treatments for this disease. And the 3 leading MND charities are proposing that we should really go for this now through the creation of a virtual UK MND Research Institute. That's going to require funding that's well beyond the resources of the 3 charities, which is why we're calling on government to join us in this vision. There's 3 basic components. The first is to develop the drug discovery pipeline, to build on all this recent understanding, start to load up that conveyor belt of potential treatments to take from the lab towards the clinic, where we have the second component waiting, which is a trials platform, a network of clinics with the expertise to run world-class clinical trials. And it has to be sustainable. That's the key thing. What's happened in the past is drug companies are like number 10 buses. They come, nothing happens for 2 or 3 years, and then 2 come along at once, and the infrastructure is built up and the trials are run, and then the drug company goes away and it all dissolves again. We need to find a way of making this sustainable so that we can just constantly feed new potential treatments through to the clinical testing stage. And the third component of that is to make sure that we're getting as much as possible out of each trial. And that means building in a rigorous clinical research program to develop better biomarkers, create better trial designs, better outcome measure, better use of new technologies. You know, if a drug works, then at the end of that, we'll know why it works, and we can move quickly into developing the next generation of even better drugs. And that's what we've seen happen in multiple sclerosis, where we've seen an explosion of new treatments appear in recent years. But also, if the drug doesn't work in the trial, once again, we'll at least know why it didn't work. And we can use this knowledge to feed back into the development process to shorten the odds of success in future trials. So we would like to send all attendees a copy of the case that we've put to the Minister for increased targeted MND research funding, and we certainly welcome comments from everybody. I do hope you find it an interesting read. It might be a challenging read in some place, but you know, we do think that this is an opportunity, and the three charities would certainly welcome your assistance in moving this ambitious plan forward at this very promising time. So my last slide is just to emphasize that we think the time is right to make this push, but it's also what people living with MND expect of us, because of course, if you have MND, time is not a luxury you can afford. And as patient representative associations, we share that impatience of the people with MND that we represent. Thank you very much.
Thank you very much indeed, Brian. That's great. Let's move straight on to Professor Chris McDermott. As I say, we'll take questions at the end of all of our three speakers, but let's move straight on now to Professor Chris McDermott, who's going to talk about the gene therapy clinical trial, which fits in very much with what Brian's just saying. Chris.
Yeah, so it would appear that this is the first time I'm using Teams on this particular computer, and it's now I'm trying to share my screen. It's asking me for all sorts of permissions. So I need to quit and reopen. I'll be very quick. I'm very sorry.
That's no problem. We'll hold on. It's fine.
Alison, I can't see Chris McDermott.
No, he's just logging off and back on again. That's
yeah,
why.
but even before he went, I couldn't see him. I'm doing something wrong. I'm probably doing something wrong here, but never mind.
I have got a copy of Chris's slides if it's easy if I try and share them.
You can do the Chris Whitty. Next slide.
Let's see if he comes back and able to share. If not, I can try and do it.
Just give him a minute, and then maybe Alison, if you put the slide up and he gets back on, he can see. He'll be able to see, won't he, straight away that they're already there.
Would it be appropriate if anybody had any questions on my presentation if I took them now?
Yes, I was going to say that Chris might have answered some of yours, Brian, but you can answer them yourself then while we're waiting. So does anybody have anything? If you could use the function, raise a hand function at the top of your screen, it would help me to keep an eye on who's here, seeing we've got something like 90 people. You'll imagine the logistics of that. Yes, Baroness Spinley, yeah.
Sorry, unmuted slowly. Thank you very much indeed for this. And I just wonder how, in a way, you see the network being future-proofed politically, I'm just thinking about the devolution type challenges over the years, because this needs to be a research network grouping that is really strong and sustainable in the long term, and not subject to forces that might pull it apart politically, depending on where it's based. But also that can be flexible enough to draw on emerging strengths in different parts of the UK.
Yeah, that's a challenging question, but I'd start first of all by talking about the strength of the clinical MND research community and the collaborative nature of that work. So one of the advantages, first of all, within the UK is that the vast majority of people with MND will attend a multidisciplinary clinical specialist centre for some aspect of their care. So this means relatively large numbers of people with this relatively rare disease coming through specific doors of a clinic. And so that means that provided we have that network in place, and we actually have that network already. You know, within England, Wales and Northern Ireland, we have, forgive me if I get this wrong, 21 or 22 specialist clinics or care centres and networks, as we call them. There are 2 or 3 in Scotland as well. So they already actually operate very successfully. There's something called the UK MND Clinical Studies Group, which actually Chris McDermott chairs, where they have monthly meetings and they actually assist with the setup and the recruitment to not just clinical drug trials, but new clinical studies as well. They're also set up to act as the conduit for international drug companies that are interested in running phase 2 and phase 3 trials in MND. So rather than, you know, what can happen in other diseases where the drug companies come and they try and pick off individual clinicians and individual hospitals, the idea is you come through the clinical studies group and then they put out that call for expressions of interest, and we actually operate as a cohesive team.
Great, thank you, Brian. So I've got questions for you, Brian, from Tim Farron, and then from Chris Evans, and then we'll go into Professor McDermott's presentation. So Tim.
All right, thanks, Andrew, and thank you very much, Brian. Really, just to get a sense from you as to what you think we can do and who it is we should be making our representations to in order to support the bid for this funding. It appears that we're looking at the Departments of Health in all 4 parts of the United Kingdom, but we would love to be guided by you as to how we can be most effective to support this bid.
I'm not a politician. I'm very politically naive, I have to say. So I would defer that question to one of my policy and campaigns team colleagues. I think what I will say is that one of the challenges here is we have drug development and then we have the testing of the drugs. And in terms of government funding, they do come out of 2 separate government departments. So, you know, what we need to do is kind of find a way of bridging that rather than trying to operate in silos. But maybe one of my colleagues will answer your question maybe after Chris's presentation.
Right, thank you very much, both. So Chris Evans got a question for you, Brian.
Thank you, Andrew. I'm going to get a plug in writing a book about Don Revie, who the Leeds and England manager who passed away from motor neuron disease 30 years ago. 2 things I'm interested in is obviously Doddy Weir is suffering. Don Revie lived a very active life. Is there any research between the connections of elite athletes and their ability to contract develop motor neuron disease? And the second point is I've spoken quite extensively with Don's family. They believe a lot of the problem was that there was a late diagnosis there, in that because motor neuron disease is still relatively rare, they had to rule out everything before they found out about motor neuron disease. And they believe that might have hindered the research in the sense that by the time you get to motor neuron disease, you're near the end of life anyway. So I'm just wondering, has there been any improvement in early diagnosis of motor neuron disease? And has that helped out in your research in any way?
Right. These answers would be quite long, but I'll try and give you very short versions. Certainly in terms of the fitness, the athleticism, many neurologists will say, well, I very rarely diagnose MND in somebody who's been a chronically obese couch potato all their lives. People tend to be fit and healthy as well, up until the point where they reach the neurologist. They actually have very thin medical files. Now, it could be that, athleticism is like a grain of sand on the scales that helps contribute to the manifestation of the disease. Could be one of these environmental factors, but it could actually be the opposite. Because we know that people with MND tend to exhibit a cellular hypermetabolism. In other words, their cells are burning energy at a slightly faster rate than the rest of the general population. And if you're inherently born with that cellular metabolism, maybe you're a bit more active as a child. And so your parents put you into the local football club as an outlet for that activity. And as a result, you stay within that sport and you actually reach a higher level. So, we just don't know whether it's cause and effect, but it's certainly an area of great interest at the moment. The diagnosis one, I think, is absolutely essential. One of the real frustrations in my 20 odd years is that we haven't made large inroads into this diagnostic delay. It maybe used to take 14 to 18 months 20 years ago. It's now maybe taking 12 to 14 months on average. But that's not good enough, because common sense dictates the sooner you give a diagnosis and treatment can start, the more likely it is that treatment will be effective. And it's quite possible that some of the drug trials that have failed in the past have simply been a case of we've been giving too little too late. We've been trying to dam that river too far downstream. So in fact, a lot of the clinical research that we're looking at the moment is actually trying to improve diagnosis, trying to understand when this disease first starts. Does it start a year before the symptoms appear, 5 years, 10 years? And the further we can go back, ideally before the overt symptoms of the disease appear, then the chances are we'll be able to develop treatments that are effective.
Well, it's absolutely fascinating question and answer there. Thank you for that. Really angle I hadn't thought of at all before. So we've got Debbie's going to ask a question of Brian, and then we'll go straight into Professor McDermott's presentation. Debbie.
Thank you. And it follows on from Chris's question, actually, in relation to primary and secondary prevention. So obviously with the levels of the prevalence levels and so on, mass screening, as we see with cervical cancer and so on, won't be appropriate. So, but what are given that you're looking at clinical biomarkers, what other ways could we screen in order to prevent individuals actually developing motor neuron disease in the first place?
Yeah, well, certainly where we know the disease runs in families, you have younger family members who can come forward and request a genetic test, like you see with the BRCA genes in breast cancer, like you see in Huntington's disease. Now, with the breast cancer genes, where you've got high risk of breast or ovarian cancer, there are clearly some, albeit quite, marked preventative steps that you can take. We don't have that in MND at the moment. There's a couple of things that can be done. The first is, if you've got a high risk gene in the family and you find that you're carrying it and you want to have a family yourself, then you can undergo what's called pre-implantation genetic determination. So that it's basically in vitro fertilization, but you can use this process to ensure that you are not passing that gene on to your children. So you have some families, where a particular inherited form of the disease has blighted this family for generations, at least that family has the knowledge that it stops and doesn't go on to the next generation. So that's pretty standard practice now. But of course, you have to know the genes, first of all, that are involved in these families. The other thing is that, you know, I said earlier that the sooner we could diagnose, the more effective treatments might be. So the companies that are working on the gene therapy approaches that Chris is going to talk about are actually starting to say, well, maybe we should be starting, in fact, they are starting a trial in gene carriers, so asymptomatic gene carriers who may develop the disease in 10 years' time, 20 years' time, 30 years' time, may sometimes not develop the disease at all. That's just the kind of genetic environmental lottery. But they are starting to look at that. And, you know, we have potential here for, at least in some of these cases, for prevention. And of course, you know, that I think will certainly for these families would open up huge opportunities for the more sporadic MND in the future. A lot of these gene carriers are starting to participate in research studies, give blood samples, CSF samples, so we can actually find out what's going on potentially decades before the disease occurs. And that should hopefully help in the development of better, more accurate and faster diagnostic tests in the future.
Thanks very much. Just got one more crept in. James Grundy wants to ask a quick question of you, Brian, and then we will move on to Professor McDermott. James.
Thank you. Yes, just talking about this. If you carry a gene that sort of makes you susceptible to MND, is this? I mean, how close is it to genetic inevitability that you get the disease? How much of it is a genetic risk? Do we know the risk factors? Is it like 1 in 10, 1 in 20, or is it? You know, if we identify these genes, I'm sorry, you're like very, very likely to develop this. Is this something we're still working on?
Yeah, I have to say these questions have all been great, and I actually have a talk on each of these presentations, but they're all about half an hour long. The short answer is, yeah, I often say these aren't causes of the disease, but in these families, they're clearly high risk. But no, the risk is not absolute. This is something we call disease penetrance. So somebody can carry a gene that puts them at risk of a disease. The penetrance is, okay, in what percentage of cases does that actually manifest as the disease? And that can be very variable, and it can be incredibly variable for all the different genes that have been discovered. So some of them are quite high risk. For example, there's one called the SOD1 gene, and there's a form which is particularly common in the United States called the A4V form of that, where the penetrance, the likelihood of developing it by the age of 70 is something like 90% if you carry that gene. But there's another SOD1 gene mutation which is found over in Scandinavia. It's the most common form in Sweden. It's called the D90A SOD1 mutation. There, the penetrance is actually only about 5%. So you can see there's a huge range of levels of risk, and that's just within 2 variants of one gene involved in MND.
Great. Well, that's perfect lead in, isn't it, to Chris's presentation. So now we've got our technology sorted. Let's hand straight over to Professor Chris McDermott to talk about gene therapy in MND. Chris.
Thanks. I'm really sorry. Thank you for indulging me with the technical issues. It gave you the chance to grill Brian, and I'm sure you found that very interesting. So I'm a neurologist in Sheffield at the Royal Hampshire Hospital. I'm a professor of neurology at the University of Sheffield, and as Brian said, chair the NIHR UK MND Clinical Studies Group. And I'm going to talk about gene therapy in motor neuron disease and focus on the SOD1 gene therapies that are being developed. But I hope also to be able to show you how although this is a relatively rare form of MND, the learning that we're getting from studying this gene and doing the trials in this gene, I think will have relevance to the much more common sporadic disorder. Okay, so we're not fully dealing with the tech. There we go. Just a leveler, motor neuron disease. If you decide that you want to move your arm, you have the thought in your brain, you send the command down wires or motor nerves, and then the arm moves. In motor neuron disease, the wires are degenerating, and so eventually you get paralysis and the muscles can't move. This is a cartoon of a motor neuron, so that's what these wires sort of look like in cartoon form. In green there, that's a motor nerve, and there are friendly cells around it that supported astrocytes and microglia. In motor neuron disease, things go very wrong. So all the stuff that just popped up on the screen there is the various mechanisms, and that's not a comprehensive picture of the things that are going wrong in motor neuron disease. And it's all these things in combination in different types of motor neuron disease that lead to those wires, those motor nerves dying, and motor neuron disease occurring. So we've already sort of touched on this. MND is not one disease, and that's been known for some time now, but really over the last decade, the importance of that fact has come to the forefront of how we approach it. So there are different ways of categorizing motor neuron disease, and one that's particularly useful, which we've heard about, is whether you describe it as familial motor neuron disease, where it's clearly running in a family, or whether it's sporadic. So on the right, the sporadic MND is the most common. So about 90% of motor neuron disease is occurring as if by random in individuals in the population. On the left, much more rare, the familial forms where it's running in families. This is itself a simplification of what's actually going on. In the familial forms, what you have is a rare mistake in a gene that's having a dramatic effect in that individual, in that family, causing motor neuron disease. In the sporadic cases that are more common, it's more complex. You've got multiple different environmental factors, perhaps, and then you've got smaller changes in much more common genes, but by themselves probably aren't enough to do anything. But with the unidentified environmental factors, the various what I call nudge factors within the gene changes that they have, all come together to give motor neuron disease. What I'm going to talk about to begin with is one of these rare familial gene changes, so the SOD1 gene, superoxide dismutase. And I'm going to talk about a therapy developed by Biogen. The therapy is called tofersen, and it's being developed and investigated as a treatment for SOD1 motor neuron disease, which accounts for about 1% of all motor neuron disease. So I think it's useful just to think what's going on in the sort of familial motor neuron disease. So with the case of SOD1, you have the faulty SOD1 gene. So think of genes as a recipe, and those recipes need to be converted through various stages into protein, and the proteins are the building blocks of our bodies, in this case the building blocks of our nerves. So it goes through several stages. The faulty protein is produced from the faulty recipe, the mutation in the SOD1 gene, and then somehow that faulty protein causes problems within the nerve that leads to motor neuron disease. Now, that's complicated, and it probably involves interactions with other things going on in the body. It's not a simple one-step process. And I think it's fair to say, for all the proteins that we know that go wrong in motor neuron disease, we don't fully understand how those changes lead to MND. There's still much uncertainty. But the special case of familial MND is do we really need to know? Do we really need to know what the faulty protein is doing, how it's leading to the degeneration of the nerves? What if we just stop the faulty protein being produced? So here you have your healthy motor neuron, all nice and green, not much going on. You then bring in the faulty protein there on the left, and it leads to all these downstream toxic effects within the neuron. So there are two approaches you could take with dealing with this. You could look at each of the, let's think of them as fires that have cropped up all over the neuron, and you could try and tackle each one. So if you look at the top right, there's something in the star, the mitochondrial dysfunction. So what if we fix the mitochondria? What if we give a compound that could improve mitochondrial dysfunction? Then at the bottom left, you've got axonal transport as an issue. So what if we also then gave a compound, a treatment that could improve the transport within the neuron? You could foresee patients being on a cocktail of treatments that deal with each of these individual issues to dampen down the problem within the nerve. That's one approach. The other approach is to get rid of the protein from the outset, the toxic protein in the outset, and then you put out everything. And that's the strategy that's been taken by Biogen, and it's an international trial. We've been leading this in the UK and Sheffield. King's were also involved. And this was the initial data that was produced in the summer of last year. So this is really recent research. And this is what's going on in that trial. This is what tofersen is thought to do. So you have the faulty SOD1 gene at the top there, going through to the faulty protein. What we're doing is we're introducing through a lumbar puncture. So that's a needle that goes into the spine. We're injecting genetic material. It's called an antisense oligonucleotide. That's the type of technology that's being used here, and that's being injected. It's called tofersen. And what the tofersen does is it mirrors the gene, the genetic code, so it can seek out the SOD1 protein. It binds to it, and when it binds to it, it triggers degradation. So the protein then isn't produced. The treatment needs to be given through the lumbar puncture to ensure it gets across the blood-brain barrier. A real challenge to giving these therapies is you need to get across the blood-brain barrier into the nervous system. And if you just swallow a tablet or inject into the bloodstream, you can design chemicals so they can then get across the blood-brain barrier. But for these types of therapies at the moment, we're injecting them straight into the nervous system. And Danny will talk about her experience of been having this therapy monthly for the last few years. So this is the design of the study. This is what we call a multiple ascending dose, or MAD study design. And this is because this was first into man. It's the first time this therapy was given to a human. So you have to start slowly. And the beginning is about safety, making sure that it's safe and no harm is being done. So you cautiously have these cohorts. So cohort 1, a very small dose is given to a number of patients around the world. You then stop. There's a very tight surveillance on individuals who are in the study. After a number of months, a safety committee reviews, looks at all the patients and decide whether we can go to the next dose. So that went on in 4 cohorts until we reached the good dose of 100 milligrams. And I'm pleased to say that the safety data was reassuring. There were no major issues. This was safe and a tolerated procedure. The secondary outcome measures were looking at what was the effect of introducing this tofersen, this genetic material, into the spinal fluid. So I have some graphs here. So the first on the left, if you look at the one on the left, first of all, this is thinking about what are we trying to do. We're trying to lower the SOD1, the protein that's causing the damage. So the blue line that goes across the center around level 1, you could see remains relatively stable, and that's the placebo. So that's what you'd expect. There's no change. But as you then increase the dose of tofersen, and if you go down to the orange line at the bottom, you can see that over the 85 days, you are seeing a suppression of the SOD1 levels. So this genetic therapy is doing what we wanted to do. It's lowering the SOD1 levels. So that's tick one about what we want. Then the next question to ask ourselves, so we're lowering the SOD1 protein, but is that having any biological effect on the sort of disease? And Brian's talked about how we now have biomarkers which give us a handle of what's going on inside the body. So when you damage a nerve, it releases neurofilament. Neurofilaments are like the scaffold within the nerves. And when you damage your nerve, you release that neurofilament. So the levels go up in the blood and the CSF. And so if you do neurofilament testing in patients with MND, the neurofilament levels are higher than they should be because of the nerve damage. What we're seeing in this trial is in blue, you can see the neurofilament levels remain relatively stable or slightly increase on that bottom figure. But when you introduce tofersen, so in orange, the orange dotted line, you see the neurofilament levels come down. So that suggests there's less damage going on in the nervous system. So we're lowering the SOD1, we've confirmed that, and we're seeing less release of neurofilament into the CSF, suggesting there's less damage going on. Other positive findings, so the caveat to all this, it's relatively small numbers and the confirmatory phase 2-3 study is going on now, but these were the provisional data. And the headlines are in green there. So this is what the individual is experiencing. So patients' motor function decline slowed. So on the graph on the left, the orange line is those receiving tofersen, and you can see their function remains relatively stable, whereas those receiving placebo in blue, over the 85-day period, their function drops. They can do less on a day-to-day basis. In the middle, breathing strength in orange remaining stable in those receiving the tofersen, but dropping over the 85 days in those receiving a placebo. At the very end, a less dramatic separation, but still a signal there. The limbs remain strong, the orange line of tofersen remaining relatively stable, a decline in those receiving the placebo. So we've now enrolled fully, both at Sheffield and in King's, the final patients in the larger cohort, and that will be reporting, well, the last patient will reach the end of their study visits in the early summer, and we hope that the reports will come out in the autumn. And I know that Biogen, if they confirm these results, are hoping to go for licensing in various territories. So it's very exciting, and Danny will be able to talk about her experience of being in that trial. So SOD1, 1%, but what does this mean for the other 99%? I think the sort of take-home message is for the first time, it looks as if MND could be treatable. If these results are confirmed, we might be making a difference in a type of motor neuron disease. So if we say 10% of patients have a clear-cut large gene effect, so, where there's a major gene change that's causing their problem, then it may be that this type of technology will be helpful for them. And there are trials underway at our centres and in other centres of C9, which accounts for about 10% of all motor neuron disease. So that would be a big breakthrough in addition to what I've already described. For the 90% with the sporadic MND, well, our understanding of sporadic MND has made major advances in recent years. And there are now many potential new treatments ready to be tested. So Brian's touched on how understanding the genetics of motor neuron disease gives us a handle on what the pathways are in all motor neuron disease that might be important. And so that's enabled us to identify pathways, identify targets within those pathways. And there's a plethora of exciting compounds ready to be tested. And they're now ready to be tested in our faster and smarter clinical trials. Again, Brian's touched on this. and also using biomarker readouts so we can get the answers about what's working, what's not, much quicker. So we're in, an exciting time about how we're going to go forward. And we are learning from the gene therapy studies. So what we're learning in the gene therapy studies and familial MND will have direct relevance to the sporadic disease. And I'm just going to sort of give an example of that. So you've got a healthy motor neuron there on the left. The key signature that a pathologist sees when he looks down a microscope at a sick motor neuron, or in any of the models of motor neuron disease that we use, is accumulation of a protein called TDP43. And so that's represented in the diseased motor neuron there with the multiple orange circles. They shouldn't be there. And then the photograph there is of a real motor neuron chock full of brown blobs. Those brown blobs are the TDP43. It shouldn't be there. It's the key signature, the hallmark of motor neuron disease. If we could get rid of that TDP43, one would hope that you would be rid of motor neuron disease. So just thinking about how genetics can help perhaps treat the sporadic disease. So ataxin-2 in 2010, so a while ago now, was recognized as a risk factor for sporadic MND. So when I talked about sporadic MND before, I talked about complex interactions with environment and these nudge factors of little changes in genes that might nudge somebody along a pathway towards motor neuron disease. Well, ataxin-2 is one of these bad nudges that you can get if there's a slight change in your ataxin-2. An exciting, elegant piece of work done in 2017, published in Nature, showed that if you reduce ataxin-2 using the same technology that I've just described in SOD1, so suppressing the production of the gene, in this case ataxin-2, you reduce the amount of brown blobs essentially within the motor nerve. So the TDP43 reduces in a mouse model of the disease, and the mice live longer in this model, this TDP43 model of MND. So that's really interesting. And what might be going on is ataxin-2, this is a simplification, it might be needed, it might be the glue, if you like, that brings the TDP43 together in this bad way that then harms the neuron that leads to ALS. If we could get rid of this glue, whatever the ataxin-2 was doing, perhaps the TDP43 wouldn't come together in the brown blobs. And this is a study is underway now. So again, by Biogen, using this ASO technology and the injections into the spinal fluid to lower ataxin-2. And hopefully the idea in sporadic MND that if you reduce ataxin-2, then you will stop the TDP43 coming together and have some benefit. And hopefully the sort of types of improvement we're hoping to see in the SOD1 gene therapy you will see with this therapy. So that's currently that study is being led in the UK out of UCL and is sponsored by Biogen. So this is my last slide. I think there are reasons to be hopeful. Gene therapies for types of MND are showing promise. The technology seems to work. The patients find this method of delivering the therapy acceptable. We've had huge advances in our understanding of the biology of the genetic forms of MND that are impacting on the wider sporadic MND. There are changes in the way we can do trials, the way we deliver trials, and exciting initiatives such as the UK MND Research Institute, I think, will allow us to pull all this together and really accelerate towards treatment for this awful illness. So that's me done. I'd be happy to take questions now, or we could move. Danny and I were going to do a sort of a chat. I was going to ask Danny some questions, and she could tell you all about what it's like being involved in one of these trials. But I could pause for questions. I'll be guided by what you want, Mr. Chairman.
Oh, well, Chris, thank you. I think given that Danny's taking part in your trials, that little chat would be a good thing to go straight into, and then we can have some questions about both that experience and some of the research you presented as well. So if I could invite you, Danny, and you, Chris, to have that informative conversation for the rest of us now, I think that would be a great thing to do, and then we'll take some questions. So Chris and Danny, over to you.
Thank you.
Hi, Danny.
Morning, Chris.
How are you?
I'm fine.
Good, good. I'm loving the artwork at the back. It's very dramatic. What is it? So obviously we know each other very, very well. Do you want to just introduce yourself?
Yes. Okay. Good morning, everybody. I'm Danny Baird, and I'm from New Zealand, and I come from a very large family in New Zealand, and I've been on the SOD1 trial in Sheffield for nearly 4 years now.
Okay. So Danny, I suppose the first question, and obviously we've talked about the things that we're going to ask today, so I know that you're comfortable with the questions we're going to ask. Sure. So you've talked about coming from a large family that have been infected by motor neuron disease. I wondered if you could just talk us through the impact that MND has had on your family.
Well, I'm the 5th member of my family because my mother had a lot of children, and I'm the 5th member, and the other 4 have died. Some have been older than me, some have been younger. It's had a terrible effect on our family. It just hangs over our heads, really. I never thought I'd get it, obviously, but everybody probably says that. But it hasn't gone down to the next generation as yet, but we're sort of crossing fingers and dreading the, any news. I get a lot of my nieces and nephews thinking they've got it. But anyway, it has had a terrible effect on our family, and it's just scary, really, for everybody.
Indeed. And how did you hear about the trial in
Sheffield?
Yeah.
I was a patient of Professor Chris Shaw in King's, and he had been involved. I'd been involved with him for about 20 years because of my family history, and I was trying to help with research. And of course, when I got it, I went to see him, and he diagnosed me the first visit. So, and then obviously I was just desperate to do anything, and he put me forward to the Sheffield one, and that's how I got there.
Okay, and so what were your motivations for getting involved in the trial? What were you?
Hope. I was hoping it would help me, and it has. So I really do want to do everything I can to help with this disease. I mean, I've seen what it's done to my family, and I know the consequences. So I just really think that it needs more done about it, and not enough people know about it even. So yeah, it's I went up to be assessed, and I got on it.
Had you been up to Sheffield before?
No.
Okay.
I know it well now.
What were you expecting? Perhaps from the trial more so than a visit.
Well, I knew it was going to be a lumbar puncture, but I didn't really know the extent that it's so thorough, and it's more thorough than I thought. Like, I'm just so well monitored all the time. The staff are amazing. My lumbar puncture now just means nothing. I just don't even think about it, to be honest. So I don't think I had any preconceptions. I didn't get on the first cohort, but I was the only one on the second one. So maybe I'm just lucky.
So I suppose if I just explain that, so Danny was entered the blinded phase, so a double blinded phase of the study for a few months, and then Biogen, when everyone has been in, I think it's 4 months, then gives everyone the opportunity to go on to open label extension, so they know that they're getting the tofersen at the 100 milligram dose, and Danny's been receiving that now at that dose, so knowing that she's receiving tofersen for the last 2 years, I think, or 2 or 3 years. So in terms of I suppose you've talked about the lumbar punctures. Let's just have a little chat about that. So it's a monthly lumbar puncture. So you've had how many lumbar punctures?
Oh, must be over 50.
So that is, you know, is a lot, and that might put people off. What would you say to somebody who was wary about having?
Well, I've heard a lot of people who are so scared they say they couldn't go and they couldn't have it. But all I can say is the staff and the doctor doing it. The doctor I've got at the moment, sometimes I don't even know he's done it. I think they're so skilled and so good, and they're also caring. And you know, it's fine.
Okay.
If it does what it's done for me, it's well worth it.
Okay.
Here I am, still alive.
And in terms of when you come up for a visit, so you come up, there's a lot more goes on than just a lumbar puncture. How long does it take? What happens to you?
I get tested. Obviously I get a breathing test every 4 weeks. I get blood tests. I get the heart monitor one. I get my muscles tested, my resistance. There's a lot. I'm very well monitored, so I don't worry about anything.
So because I suppose that's because we're looking at the safety. It's still few numbers of patients that have had this treatment so far, so it's important that we continue to closely monitor people. But the visits are long, as you say, but we try our best to be mindful of it not overtiring you, and you get plenty of coffee. And
honestly, I can't say enough praise about the staff.
Okay.
They've all come from my friends, really. I feel very comfortable there.
One of the things, perhaps, just to follow up on with the lumbar puncture, just for the benefit of the audience, the way that this technology will evolve, at the moment it's being given by lumbar puncture and it's repeated dosing. There are technologies out there, so viral vectors, for instance, where it's hoped that a one shot will then get the new DNA material incorporated into an individual's genetic code. So they only need one shot, and then the treatment is continually secreted into the nervous system. The other options are little reservoirs. So instead of having a lumbar puncture, you have it's like a hockey puck reservoir that can be inserted into under the skin, and then you just inject the treatment into the reservoir that then it flows into the CSF. So there are other technologies that I think, once the principle of the ASOs is proven, other technologies will make delivery easier. It's that you've been receiving tofersen now for the last 2 or 3 years. Danny, what do you think it's made to you? So if you think about life before you were receiving it and since you've been in the trial, what difference have you noticed?
Well, it stopped progression for me. I can't do it. Hasn't cured anything, but it's totally stopped progression. So I can still look after myself. I've still got upper body use. I've got. It's just given me hope, and I'm just much more relaxed because I know I'm not going to die, in a couple of months. And it also gives me hope for I've got 2 daughters, and it gives me hope that something can happen if they carry the gene. I've been told it's a 50-50 dominant gene. I don't know whether that's how right that is, but they won't get tested at the moment because they're scared, I think. Mm-hmm. Until there's a definite sort of cure, or not a cure, or a slowing down. But it has changed my life, without a doubt.
Okay, thanks, Danny.
I'm just so much more happy now, and happier because I don't have to sort of think about all that morbid. I wasn't really scared about it before because I'm quite a positive person, and I thought, well, nothing I can do about it. I've just got to get on with it. But now I don't have to think like that.
Yes, I was going to say, you've never struck me as anyone. Well, you're always very happy.
Yeah, I am happy.
Okay, I think that's my questions. Is there anything that you want to say, Danny, that we've not talked about that you think it's important?
I just hope that more of this can happen, and I know I'm only a very, very small portion of people with MND, and almost feel guilty that I'm getting something that's helped me, and yet there's so many people out there who are so it's such a sad disease and it's so brutal, and I just think that, oh, you know, it's really awful. And I just hope that there'd be something that, like you've been just saying, the trials can continue and you can concentrate on sporadic. That's about all. Thank you, Chris.
Thanks, Danny. I think it's worth saying you are selfless as usual, but the burden of taking part in these studies is not small.
No.
Monthly visits. So you've given a lot in terms of enabling us to advance our understanding of the disease. You know, subjecting yourself to monthly lumbar punctures, etc. First into man studies. You know, the outcomes look positive, but you don't know at the start. You have given a huge amount.
Thank you. I'm a pioneer, Chris.
Indeed. Okay, Andrew, I think that's us.
Thank you. Well, thank you both very much for that. That was very, very informative. And Danny, we really appreciate you coming on and talking so openly about what's happened. It's something we sort of specialise in at this particular all-party parliamentary group, that we do like to hear from people who are actually dealing with the disease, either themselves or their nearest and dearest. And it does add a very important element, I think, to the meetings, and therefore to colleagues' determination to do everything we can to help. I'm going to have a few bits of Q&A and bring Brian in, as well as Danny and Chris, to them. The first two questions I'd like to invite are from Jeff Burrow, who's Rob Burrow's father, the rugby league player that you'll know. Jeff wants to ask a question, and then I'm going to ask Kevin Sinfield, who's run 7 marathons in 7 days for MND, and he'd like to make a comment as well. And then we'll move on to a few more quick Q&As, and then I want to get on to the terminal illness review with DWP and Jessica. So Jeff, could I ask you to come on, please? I can see you, or I can see GB. Jeff, if you can take your mute off.
Can you hear me now?
Yes, can hear you now.
Sorry about that. Yeah. Well, thanks for the opportunity to address this committee. Chris McDermott, I've listened intently to all of the presentations, but with Chris, you know, he's kindly treating Rob on a treatment, and Rob's he's at our house today, and he sends his regards to everybody, and to give a wave to Chris and thank him. I mean, my question, I think it's probably been answered in some degree, is that you know, it was about effective or more effective treatments and how near we are to a cure. Now, I know there's no answer to how near we are, but the confidence I've taken from listening to everybody is I believe it's getting nearer. And you know, I can just speak on behalf of Rob on the treatment that he's been testing. And again, as a dad, you know, you're looking for improvements. You're looking to see if it's getting worse. And without any medical knowledge, I can say with confidence, and I've said it to Rob, and Lindsay, his wife, said it to him, it does seem to have slowed the degeneration, you know, it getting worse. Rob sometimes doesn't believe us, but you know, I really have noticed a treatment, an improve. Well, it's steady. You know, there's been no getting worse. He can still walk assisted, and he's like Danny, that's just been on. Nothing but positive, smiles all the time, and so I think, you know, my questions really, unless anybody's got anything else to say. I'm really positive and really confident after listening to everybody's presentation. So you know, I welcome any comments, but you know, if not, then thanks for this opportunity.
Jeff, thanks very much, and everybody's best wishes to Rob. Thank you for giving us an update there. Just invite Chris perhaps to respond to that, and then we'll move on to Kevin. Chris.
Thanks. Hi, Jeff, and do say hello to Rob for me. So I think you're right. I think progress has been slow, but there is a sense, I think, in the sort of research community and with everybody else who are coming together to to fight motor neuron disease and find cures, that there's going to be a pace of change. We understand much more about the biology now. 10 years ago, we didn't really know what was going on in the nerve, in the neuron. I showed the picture of those brown blobs. We didn't know what they were. You can't treat something or make something go away if you don't know what it is. So that's just a very, a simplistic description of the huge changes that have been made. And some of the compounds that are coming forward and are going to go into clinical trials, they're impacting key pathways, the central pathways in motor neuron disease. So one is much more optimistic, that we're looking in the right place. There was a sense, perhaps in the past, not always, that we were almost randomly just testing drugs without a strong rationale for why they were being tested. I don't think that's the case now. There are a list of medications which have a strong rationale that we need to get in clinical trials quickly. And Brian talked about the new trial platform, SMART, TriCals, Healy in the US. We're going to get through these and get answers much quicker than before, when a clinical trial would take, for one compound, would take many millions of pounds and 5 years from the first idea to decide to take it into a study, to setting the study up, running the study and reporting it. It's going to be faster. I will be frank, it's still not fast enough, but we're going to be going a lot quicker than we have been, and we need to.
Thank you.
Thanks very much, Chris. Brian, you want to chip in there as well?
Yeah, it's maybe a much more unscientific measure, but I organised the annual International Symposium, and what I've noticed over the past 5 years in particular is the number of delegates with drug company names on their badges. And that can only be a good thing, because, if we're going to crack this disease, it needs the investment of industry. And the fact that these people are turning up at this conference means they have an interest in MND. And, I'll be frank, drug companies aren't here to make the world a better place. They're here to make money for their shareholders by selling drugs. But the fact that they think that MND is a disease that they can develop effective drugs for, I think, is a very, very positive message.
Thank you for that. Kevin, I'll bring you in, and then Diane has typed a question, but I might just ask her to actually ask it on screen. But over to you first, Kevin.
Good afternoon, everybody, and thank you, Andrew. I just want to thank everybody for the invitation to listen in to today's meeting. I think it's been really informative and really useful for everybody. I'd like to thank all the MPs for your continued support and interest. I think it's wonderful what you guys are doing and the way you're pushing. And then lastly, just my final comment, just want to congratulate the MND Association, MND Scotland, and My Name's Doddy Foundation for the collaboration that is going on to try and work together to get some results with this. So just a big thumbs up for me, and thank you, everybody.
Well, thanks, Kevin. I mean, we obviously want to give you a big thumbs up for 7 marathons in 7 days. Absolutely phenomenal achievement. I think most of us would regard running 1 marathon ever as a pretty daunting and phenomenal thing to do, but 7 in 7 days, absolutely amazing. So thank you for your fundraising efforts there and for what you've had to say today.
Thank you.
So Diane, it's a good question. Do you want to actually ask it?
Yes, please.
Yes, go ahead.
I'm Diane. I'm actually attending on behalf of Ian Blackford MP for Roscoe and Lochaber. And I just want to say thank you to everybody. I've found this very educational, very educational and informative. My question was, are you envisaging, I don't know how long in the future, but obviously in the future at some time, that with earlier diagnosis or screening tests, the tofersen treatment could be developed into further treatments that could effectively treat every type of MND and start treating people earlier so they have improved quality of life for longer?
Thank you, Chris and Brian. Chris, perhaps first.
Okay, so I suppose a very good question. So tofersen, it needs to be confirmed. So the exciting preliminary data, and then we should know for certain, whether it's going to meet the criteria to be an effective treatment of SOD1. For people with SOD1, Brian talked about there's a study about to start called Atlas, where asymptomatic mutation carriers will join a surveillance program and will monitor their neurofilament levels through life. So they'll have regular neurofilament levels tested. This was this marker of nerve damage. And if it increases at any point from the baseline, then they'll be randomized to receive tofersen or not. And that type of work is going to, give us information about, for people who we know are at risk of motor neuron disease, is there a role for screening with neurofilaments on a regular basis? Can it pick up the first changes? Because by the time we see somebody in the clinic with motor neuron disease, they may have lost 80% of their motor neurons silently before we realize. If we pick up the first signals with a neurofilament, then change, we can intervene earlier. And the way to understand that that's ever going to be possible is to do it in the genetic types first. If we show that that is something that is plausible, then if you could, I mean, this is, I suppose, extreme speculation now, but you could imagine neurofilament or something else being a bit like PSA for prostate cancer, where you have a screening test at a certain interval to see if you have a neurodegenerative disease that's starting. And then that might make you go and see a neurologist who will work out what it is and initiate treatment. So there's a lot of learning to be done, but I think the fact that you're asking that question and that I can give a reasonable hypothesis about how things might turn out is testament to, that is possible. But I don't know at the moment. I've speculated there, but I think that we are developing therapies. There's no doubt that the sooner you introduce the therapy to stop degeneration, the more impact you're going to have. So I think developing screening tools will be important, and it might be neurofilament or something else, but we're beginning to look at that now.
Thank you, Chris. That's very useful. Now, I don't see any hands raised. I was chairing a meeting of 70 people on housing yesterday, and as soon as I said that, 7 of them popped up. But at the moment, there aren't any, and I do have a final agenda item I really want to put some time in. So if we're happy, I'll thank Brian and Chris and Danny especially so much for being here and for helping for us to be so much better informed about some quite complex matters related to trying to defeat MND. And we'll move on to the final agenda item, which is to give an update on the DWP terminal illness review. As colleagues will know, that's MND's association's Scrap 6 Months campaign with Marie Curie and others as well, to reform the way people who are terminally ill are supported by the welfare system. And we've had a huge amount of entirely cross-party support for the campaign. So thank you for everyone who's been involved in that. DWP announced a review in July 2019. We're obviously 19 months on from that, and we haven't got the review actually out there. And we had been hoping for an announcement in the budget. I know colleagues have had lots of meetings. I've had meetings with the Secretary of State, with the Minister of State, with ministers in other departments. But the most current and up-to-date efforts have been with Jessica Morden here, who got an adjournment debate on this topic in Parliament last Monday, and I wanted to invite Jessica to speak to us and provide us with an update from that and what she's heard subsequently. So Jessica, over to you.
Oh, thanks, Andrew. And can I just say what an amazing range of presentations this morning. It's been really, really informative. So I just wanted to say a big thank you really to Motor Neurone Disease Association and all those who obviously helped me prepare for the adjournment debate that we had on Monday night, and all those people who kind of let me tell their stories really. And a big thanks to all the campaigners out there, of which there is a mightily huge community, because the social media support on it was really fantastic, and it really did help raise it up the agenda, I think. I was really lucky to get the debate, because we haven't got Westminster Hall at the moment. There are only really kind of 4 little slots for backbench debates. So we had the half-an-hour debate on Monday night, and in normal circumstances, I say this to colleagues who are on the call, would have, you know, clearly flagged up to people to come along. So if anyone was watching and they thought there's nobody there, that's because obviously we're discouraged from coming into the building really. So I know there were lots of people watching online, so thanks for that. Obviously you get kind of 15 minutes to say your piece, and then the important bit is getting the minister to respond. I know for people who will have wanted a kind of firm set date on when this change, the scrap 6 months, will happen, that date didn't come out to the ministers. We didn't get a kind of exact timeline from the minister on Monday night. He did reiterate, he confirmed that he wanted to tackle the 6 month rule at least, although there wasn't really a mention of the 3 years. So that's something we'll have to come back to. He did reiterate he understands the importance of the issue and talks about the consultation and the review, the lack of consistency in the system, and he reiterated again the need to also drive up awareness of lack of support. He apologised for the delays and talked about the complexity of the issue and a number of issues, and the need to bring clinicians, engage with clinicians and work with GPs in the NHS generally, and have a UK approach to it. I know people had wondered whether it was stuck with the Treasury, but he did say to me afterwards that wasn't the case actually. So that there were other COVID delays kind of relating to the Department of Health that made it challenging. So the words we had were, in the coming months I will set out the timetable. And that there'll be a health and disability green paper with some of this coming within weeks. So I just thank you all for the support for Monday, and we keep going and work with anyone really to see what we can do from here. I did, with Alison, ask for another meeting in the debate for us to chase up and get some of the detail, tackle some of the detailed reasons why we didn't have a fuller response on Monday night. So I'll leave it at there. That's where I am, unless Alison wants to add anything.
Well, thank you, Jessica. Thank you very much for getting that debate, which was a very helpful way of raising awareness of what's been, as you know, and several other colleagues on the call know, has been a sort of long-term, largely behind the scenes meetings, pushes and prods. And I'd had that just back from Treasury just ahead of your adjournment debate, that it sort of, not us sort of comment, but we do await that detail that you're seeking to work out. We can put a bit more pressure on, because I think it really helps. So with that, and with it being 12:30, I'm going to thank everyone for attending. We've had a huge attendance, well over 90 people at one point today, especially to you, Danny, but also to everyone else who's put time into this. We'll obviously keep in touch with MPs, get them to encourage the funding for MND research, but also the progress on scrap 6 months as well. Thank you again. We'll be in touch when our next meeting is on. Thank you for the re-election, which went very smoothly, I'm pleased to say, if only all elections went that smoothly. And we'll be in touch with more information as soon as possible. Thank you all very much for your time. Bye-bye.